As we've been talking about memory leaks and retain cycles, I thought this was a good opportunity to have a look at one of the new features in Xcode 8, which helps us visually find things like retain cycles and causes of leaks. So let's look at this, albeit very contrived, example where I have a view controller which has a optional property called model, and I'm going to instantiate an object of type parent object. Now that's a class, parent object, and so model is a reference to an instance of parent object. Because it's a reference, it has a retain count, and in this case there's only one owner, that's view controller, or in other words it's only got one strong reference pointing to it. Okay, so in parent object, automatically when it's constructed, or initialized I should say, it will instantiate an object of type child object, and that reference will be stored in the property child, again optional. Now, because child object has one strong reference, it's owned by parent object, so it too has a retain count of 1. Now, the interesting observation, or the key observation with this, is if we go back to the view controller and we nil the property model, like so. Now, this is not a garbage collected environment. This uses an automatic reference counting. So that will be detected, and the retain count of the parent object will now drop to 0. When a retain count drops to 0, the parent object will be deallocated, thus removing the strong reference to the child object. So that will drop to 0, and that will be all deallocated. So we're back where we were, simply by nilling out that initial reference model. Okay, so let's look at a variant on this now, where the child object has a reverse reference back to the parent. It may be dealing with network transactions or something and sending data back to the parent model object. Who knows? Now here I've used a dashed line to represent a weak reference. Therefore parent object has got a retain count of 1 because it's only got one strong reference to it. Okay, now that's fine. If you do it properly, you'll get exactly the same behavior as I just showed you. The problems come is when you forget to make that weak and you end up with this retain cycle. And because we have now 2 strong references to parent object, of course its retain count is now 2. If I was to deallocate parent object, or set child to nil, that would basically cause the child object to disappear, the parent object retain count would go down to 1, and then we could nil the model property, and that would be okay. The problem here comes is when you nil model. Okay, you do that, the parent object retain count comes down to 1, and that's it. Okay, so the child and the parent are keeping each other in memory, and they are an island out in memory. And the great news is that Xcode can now detect many of these scenarios, and that's what I'm going to show you now. So let's switch to Xcode. So I've got a couple buttons here, each with a respective action, and everything is in this view controller.swift. So here's our view controller. It's unimaginatively called view controller, and these are the 2 actions. So do alloc and do nil. So do nil simply sets the model property to nil, so that should in theory cause the parent to deallocate, whereas this one, it will just re-instantiate a new parent. Now what should happen is the old one should get deallocated and the new should replace it. So it achieves much the same thing. Okay, and it's the same idea as I talked about earlier, that model is an optional. Here's the model object. It has a strong reference to a child. In the constructor, or initializer as we call them in Swift, we instantiate a child object passing self as a parameter, so that in the child object we can take this reverse reference and set it back to the parent. So that's your reverse reference, and you'll note that this should be weak but it's actually not. So by default this one is strong. Okay, so this will cause a leak. So let's have a look at it, and we'll use this new tool in Xcode to find this cause of leak. So let's run it on the simulator and have a look. Let's just get the simulator on the screen. And off we go. Okay, bear in mind I'm on pre-release software here, which if you have a developer account you can get and try yourself, but if we have any issues, then well, that's what happens with pre-release software sometimes. So I'm going to simply click allocate. What did that do? It instantiated a new parent object and set the reference to model, which in turn will instantiate a new child object, and there'll be this reverse reference back. So if we click this new icon down here, you view this memory graph. Now let's look over here and we find view controller. Okay, but we also find parent object and child object. So parent object, we can see, well, here's view controller, there's the window, it has a root view controller property. View controller has a model property pointing to the parent, and if we go to the child we can see how that was created. Well, there we go, from the parent we have this child property referencing the child. What it doesn't show you is the reverse reference, unfortunately. I'm not entirely sure, but I think this tracks memory allocations, hence we get these references. Right, so that's the normal running situation. Now when I go into the simulator again, if I click nil, that should nil the model property. Before I can do that, however, I need to resume execution by clicking this button. Now we click nil. Now let's go back into the memory tree and have a look at it. And oh, we have a runtime issue indicated by this purple exclamation mark. And what is it saying? It'll be saying something about leaked memory, I suspect. So yes, one instance of parent object leaked, and same for the child, which is correct. It's what we expected. Okay, so this comes under the runtime category of error, which is new in Xcode 8 as opposed to build time. So it's capable of actually finding these leaks. So if we click on this, indeed, there it is. An island in memory, the parent object referencing the child and the child referencing the parent. Click the little 2 and you'll see there are 2 references. You can select each one, and in the inspector we see that is strong, and that's strong as well, hence the retain cycle. Okay, let's resume execution, and I'll do an allocate. I'll allocate another one. Okay, let's have another look. Go back in. And indeed, yeah, we've got one that's live, which is the correct object, child object there. But we've got this other one here that's just leaked and hanging around in memory, which is what we looked at just now. So if I keep doing that, let's resume. Keep clicking allocate. Right, that should be releasing the old and retaining the new. Back to the memory tree. And you can see now we're collecting quite a lot of these objects in memory, which can't be reached from anywhere else. Right, okay, so let's go fix the bug and look at the difference. Well, it's very simple. The child object reverse reference back to the parent should be weak. Build that. And let's try this again. So run. Just waiting for that to come up. Here we go. So let's just keep clicking allocate. Previously that just built me lots and lots of instances that leaked. Now we go back to the memory graph. No runtime error reported. We have a parent object. We have a child object. That's absolutely fine. No leaked objects in memory. Resume. I can nil the parent one now. So let's go and have another look. And just the view controller. No parent, no child. So that, I think you'll agree, is a very useful tool. Again, I should stress this is a pre-release version of Xcode 8. So things may change, but the feature was featured at WWDC and openly discussed. And there's a really good video on Xcode debugging. I suggest you check it out.